Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode BiWeekly contest 83. It's a medium level problem. The problem name is design a number container system. So the problem says that design a number container system that can do the following: insert or replace a number at the given index in the system, and return the smallest index for the given number in the system, right? So implement the number containers class, where obviously the first one is a constructor that initializes the number container system. The second one is so you have a function change which takes an index and a number and fills the container at index with the given number. Now if there is already a number at that index, you just replace it. There is the third function int find, which takes a number and returns the smallest index for the given number, or it returns -1 if there is no index that is filled by the current number, right? uh, a basic implementation based problem, I would say relatively easy than other level 3 problems in the Leetcode contest, right? So let's directly jump to the approach, I would say. Yeah, let's directly jump to the approach. Nothing fancy, to be very honest, nothing fancy. What we have done is just take two maps. One basically has a mapping of from let me take like this: number to indices. This tells that the current number is present at these number of index, right? So there can be multiple indices. Keep them in sorted order. So how we can keep them in sorted order? We can take a map of integer comma tree set, right? Tree set of integer. So by default these values will be sorted, right? So this is, let's call them number to indices. Let's call this is the first map. Let's take a second map. This will be a simple map of integer to integer. I'll tell you why we need this integer to integer, and the name can be index to number. And the purpose of this map is so that you can tell whether there is a number present at this particular index or not, right? So this will tell, suppose someone says that find, or suppose someone says that replace the number at index number 2 with value 3. So all you need to do, you just go to this one and just update the value. So this is the purpose of this map. And the first map is basically, suppose there is a number 2 and that is present at index number 0, 2, 3, 10, something like this. So this tells us this number is present at these indices, right? So this is the main logic of this one. Now nothing fancy here. All we need to do is that we already have two maps. The main thing is change function, right? This is the change function. So change function takes index, right? It takes index and it takes a number, right? So all you need to do is that check whether this particular index to number contains this index or not, like whether you already have a value at this particular index or not, right? So what do you do? Suppose you have a value, then all you need to do is that for this particular value, see what are all the indices. You can fetch it from here, see what are all the indices, and from the set of indices remove the current index. Because suppose a value of 10 is present at index number 5, right? Suppose a value of 10 is present at index number 5. Now someone says that at index number 5, now you put value 20, right? So what I have done, at index number 5 I have 10. So that means for 10 I have a tree set which contains 5, right? Because the number 10 is present at 5 index. Now if I replace the number at index number 5, the number now is 20. So that means I need to update my map so that now 20 has a set of 5, right? Or any other indices. So that is why what I do, first I fetch that what is present at the current index. I fetch what is the number that is present in the current index, and then I fetch that what are the other indices at which the number is present. So I basically fetch that tree set. All I do, I remove the current index because this index is being updated, and if the tree set becomes empty, I remove this entry from the map. I remove this entry from this map because initially there was a value present 10 in my system. Now if I have replaced 10 with 20 and I don't have any value of 10 in my system, then just remove this entry, right? Because your set is empty. Now all you need to do is that you put the new value in the map. How you do that? You update this particular thing. So that means now it will have that at index number 5 you have 20, and then you update this map. What you do something like this, that 20 is present at index number 5. Now if someone says that also add also put number 20 at index number 10, then all you need to do, you just need to do all these things, and now 20 will have 5 and 10 because 20 is present at indices 5 and 10, right? So this is the basic implementation. Now if someone asks you the second thing, so the second thing is find. Now find says that for a given number return the smallest index, right? So if that particular number is present here, if that particular number is present here, so that means you have a tree set. So from that tree set, return the first value. However, if that particular number is not present, because we saw that as soon as value 10 was replaced, 10 was not present in our system, so we remove this entry. Now if someone searches for 10, so we don't have that entry in our map, so we return -1. So that's the implementation. Let's look into the code. Very, very simple one, nothing fancy. I've created two maps on line number 5 and 6. We have initialized it, and then you can see the change function. So again, change says that the given number that you are trying to remove, so index to number, does it have that particular number, right? Do we have that number? So I check what is the number present there, and then on line number 14 I say that for the current number, give me the set. Now I remove from that set, I remove the current index because this index is being updated. Now if set becomes empty, so remove the complete entry from the map, remove the current number, else you put it back, right? Or that will just be replaced. I think we can remove this line as well because that is by reference, so we don't need to do it explicitly. Now line number 23, index to number is being updated, that now this index has the new number, and then we get the tree set for the new number, we add the current index, and then we update our map, right? So this is the core logic. Now if I come to the find function, so nothing fancy. All you check is whether the current number is present in our system or not. If that is not present, return -1, or you just return the first entry from the tree set, right? The property of tree set is it stores the number in sorted format, right? Tree set stores the number in a set in sorted format. Tree map stores the keys in a sorted format. Tree map does that. So the tree prefix basically tells you that the values that you are persisting in that particular data structure, those are present in a sorted order, right? So yeah, I hope you learned something new from this video. These type of problems basically test your data structure knowledge. So yeah, do support this video by giving up a thumbs up. Do subscribe to the channel, and also if you have any queries, do mention that in the comments. I'll try to resolve those. Okay, yeah.